positive versus negative correlation. Strength of association. And outliers. I don't think I had the right name up there today, but you guys should be able to see that. Let me make this a bigger screen. Whoop. Okay. So our learning target for Unit 6, Lesson 2, it's a long one, I'm sorry. It's I can determine the type of association that exists between two variables, the strength of the association, and identify any outliers. Man, I got some typos in this one. Strength of the association. It's supposed to be 1T. Association. Wow, not an N. ASSOCIATION. Okay, so I want you to pause the video, read the do now, and try the do now. Okay, and again, you can pause the video and write down the learning target because it was up there. Okay, I hope you pause the video and try the do now on your own. Okay, so this question says, the scatter plot below shows the relationship between the outside temperature and the number of cups of hot chocolate sold at an event. Which statement describes this data? So, it's always important whenever you read a graph, you should first look at the title of the graph. It's talking about selling hot chocolate, right? Hot chocolate sales. And then on the X and Y axis. On the X axis, we have the outside temperature in degrees Fahrenheit. So 20, 40, 60, or 80 degrees. It goes up to 100 degrees over here. And then the number of cups sold, counting up by 20s, 20, 40, 60, 80, 100, 120, all the way up to 140 cups. So, I don't know about you, but I like to drink hot chocolate when it's cold in the winter. So, my instinct is telling me that more cups of hot chocolate are going to be sold when it's colder out. That's what I'm kind of thinking about if I'm thinking about real life. So let's see what this data says. So let's read our answer choices. So the first answer choice says there is no association between the outside temperature in degrees Fahrenheit and the number of cups of hot chocolate sold. So this is definitely not true, right? If there's no association, that means that there's no pattern and that the dots would just be randomly scattered all around and I wouldn't be able to see a pattern. I can definitely see a pattern here. It looks like these lines are going downhill and they loosely resemble a line, right? Kind of like a rectangle going downhill. So A is out. B says there's a nonlinear association between the outside temperatures in degrees Fahrenheit and the number of cups of hot chocolate sold. So we didn't learn about nonlinear association yet, but this is definitely a straight line kind of association. I was able to draw a little rectangle around it. So it's definitely linear. It's not nonlinear. There's a positive linear association between the outside temperature in degrees Fahrenheit and the number of cups of hot chocolate sold. Well, this rectangle, if I slide from left to right, is going downhill, which is a negative slope. It's not a positive slope. It's a negative slope. It's going downhill from left to right. So this doesn't make sense either. Okay? This is a negative linear association. So answer choice is D. It's going downhill from left to right. Okay. So to recap what we learned from Unit 6, Lesson 1, last lesson, we talked about some scatter plots. And we said that scatter plots, we had three options yesterday. We had a positive correlation, which we also call positive association. And that's when you can draw like a rectangle around the points that kind of looks like a line, right? A rectangle is similar to a line. It's straight, right? It's going uphill, positive slope. So positive correlation. Negative correlation, the points look like a rectangle going downhill. You can draw a rectangle around the points going downhill. Negative correlation. No correlation. Has random points scattered all around. There's no relationship between the x variable and the y variable. Now, we also have another type of association exists. Okay? So if I look at this picture, I can see there is some sort of relationship between these points. It kind of looks like a rainbow or a sad face or an arch, but it's definitely not a positive linear or negative linear correlation. This is called a non-linear correlation. Right. The points in the scatter plot are related, but they do not look like a straight line. So pause the video, take these notes, and we're going to move forward. So relationship A, right? So the directions say for each relationship shown, determine if there is a positive linear association, a negative linear association, no association, or a non-linear association. And be careful, no association is not the same as non-linear association. No association means no pattern. Non-linear association means there's a pattern that I can see, but it's not a straight line. Okay. So I'm going to try A, B, and C, and then have you guys do D, E, and F, and I'm going to move on to the next topic. We have a couple of little skills we have to learn in this lesson. So, relationship A, I do not see a pattern. I see dots, points randomly scattered. Okay, so this is no association because there's no pattern. Relationship B, the points as I slide to the right tend to be going up. And I can definitely draw like a little rectangle around these points that resembles a straight line going uphill. So this is a positive association. So if you can trap those points inside of a rectangle and it looks like that rectangle is going uphill, it's a positive association. Okay. Relationship C is a little different from what we've seen. It kind of looks like a straight line at first, but then I realized that, hey, like it's not a straight line. These things are kind of curving down like that. It's got a curve to it. Okay? But there is definitely a decreasing pattern, okay? But this is non-linear. Okay? That's a non-linear association. Or a non-linear correlation. Okay, so pause the video. Try questions D, relationship D, relationship E, and relationship F. The answers will be in the binder in the classroom. I want you guys to try those on your own. Okay, so now let's mention strong or weak association. So we talked about the type of relationship or association that can exist, but now we want to know how strong that relationship is. So we say a relationship is strong. A strong association exists between two variables if the data points are very close together. Okay. The data points need to be close together for a strong association. If the association is weak, then the data points are going to be spread apart. Okay. So there's two situations. Strong if they are close together, and weak if they are spread apart. Okay. So for these scatter plots down below, determine if the association shown is strong or weak. So that's one thing. And if the association is positive or negative. So for relationship A, the points are very close together, right? They actually almost look like they're touching the same line. This is a strong association because the points are very close together, and it's clear that these are going uphill in like a straight line fashion, so it's positive linear. For relationship B, these points are much more scattered out. They're further away from the line that's drawn than this one. Okay, so these are more scattered out. This is a weak linear relationship, and it's a negative linear relationship because the line is going downhill. So again, I want you to pause the video. I want you to try answering C and D on your own. Check with your classmates or with a binder to see if you got C or D correct if you were not here. Pause the video if you need to catch up. Okay, so our last piece of notes. And then we'll do 2 questions. Because we have outliers. So an outlier, L-I-E-R, is a data point that does not fit in with the rest of the data. Visually, it is noticeably far away from the rest of the points in the scatter plot. So I have an outlier here, and I have an outlier here. Okay. Notice how the points in this relationship, it's a weak negative association, except for this one is really far away from the rest. This would be a weak positive linear association with one outlier because it's a rectangle going uphill, and there's one outlier that's right here. So outliers are points that are further away from the rest. Okay, we're going to skip where it says let's recap all of this information for now. And I want to do 2 more problems with you guys, and then your job is to finish the rest of this page. Okay, make sure you read the directions.
At this time, teachers were dismissing all students on the 200 floor. All students on the 200 floor. At this time, all students should be dismissed. Have a great afternoon.
Describe the following scatter plots by circling all of the words that apply below. If there's no association, then write no association on top of the scatter plot. Make sure you guys pay attention to this one. If there's no association, write no association on the top of the scatter plot. Okay? Don't circle anything else. So, for question number 4, I see that all these points look like they're going up except for this one. This one's far away from the rest. It's my outlier. I'm only going to pay attention to the other points in the graph. So I have a rectangle going uphill. This is going to be a linear positive relationship. It's pretty strong. These are pretty close together. Right? It's a thinner rectangle because they're closer together. And there is one outlier for sure. This is my outlier. Okay. Number 5. This looks like a rainbow or an arch. So this is a non-linear relationship. It's definitely not a straight line. The points are all pretty close together to each other, so this is a strong non-linear relationship, and there are no outliers. Okay. Outliers are 1 point or 2 points far away from everything else. Okay. So I want you guys to finish the rest of this page. You have all the information you need to finish up to question 11 and the multiple choice practice questions from the state exams. Okay? I hope you enjoyed the lesson, and I hope you have a great rest of the day, and I will see you in class.